This video will cover how to use Cramer's rule to solve a system of equations with two equations and two unknowns. Again, this is an alternate method that is going to use matrices and determinants in order to solve a system of equations. So Cramer came up with this rule. That's why it's named Cramer's Rule. He's a mathematician. I believe he's Russian, but I could be wrong about that, so don't quote me on it. And what he discovered is that if you have a system of two equations and two unknowns, x and y, written in standard form, so ax plus by equals e, cx plus dy equals f, where a, b, c, d, e, and f are real numbers, then the solution, xy, can be found using determinants. What we do is we're going to divide two different 2 by 2 determinants. The bottom determinant will be the determinant of what's called the coefficient matrix. So that would be A, B, C, and D. So essentially we have an x column that's the coefficients off of x, and a y column that's the coefficients off of y. We would then do that 2 by 2 determinant. Up on top, for x, what happens is the x column of this same matrix, so A and C, gets removed and replaced with the answer column. So E and F becomes the first column, B and D remains the second column. If we do these two determinants and then divide the results, we get the value of x. Y is similar. It also has the coefficient matrix on the bottom. And on the top, instead of replacing the x column, we replace the y column with the answers. So that's literally the process we're going to use to do these problems. Now we're going to do a number of 2 by 2 examples, and then there will be a separate video that shows how Cramer's rule can be applied to a larger system, a 3 by 3 system. So here is a system of two equations and two unknowns. We are going to use Cramer's rule. Now again, the x coordinate would be given by two 2 by 2 determinants. The bottom determinant would be the coefficient matrix, which the x column would be 5 and 2, and the y column would be 7 and negative 5. On top, the 5 and the 2 would get replaced with the answers. So the first column would be 13 and 13, replacing the x column with the answers. And the second column would be the same as the denominator, 7 and negative 5. Now remember how 2 by 2 determinants work. We multiply the positive diagonal and then we subtract the product of the negative diagonal. So it would be 13 times negative 5 minus 13 times 7. Same on the bottom. So 5 times negative 5 minus 2 times 7. Then we're going to simplify each of those down to a single number. So we just plug that in the calculator. 13 times negative 5 minus 13 times 7. That is negative 156 divided by negative 5 times 5 minus 2 times 7, which is negative 39. Then we simply carry out that division. Negative 156 divided by negative 39, and we find out x equals 4. Now y is actually even easier than that, and the reason for that is we already know that this bottom determinant is the same determinant. So we don't have to redo this determinant. It's the same determinant. We know that is already equal to negative 39. So all we have to do is the top determinant. Now remember, on the top for y, the x column will remain the x column, and the y column will be the one that gets replaced with the answers. So we would be doing the determinant of 5, 13, 2, 13. That would be 5 times 13 minus 2 times 13. Plug that in the calculator. We find out that that is 39 divided by negative 39, which means y is negative 1. Now, ladies and gentlemen, this is a system of equations, which means you are expected, just like in algebra class, to present the answer as an ordered pair. The solution to this system is 4, negative 1. Now, if we wanted to check and see whether or not we were right, we would simply plug in x equals 4 and y equals negative 1 to both equations to make sure that they're true. Let's do another one. So here's another system of two equations and two unknowns. This one contains some decimals. It doesn't matter that they're decimals. This process is still exactly the same. So for x, the bottom determinant will be the four coefficients. 1.5, 2.2 are the x column. Negative 0.7, negative 0.6 are the y column. On top, we are going to replace the x column, 1.5 and 2.2, with the answer column, 0.5 and negative 7.4. The y column will remain the same, so negative 0.7 and negative 0.6. So again, that process is always the same, 0.5 times negative 0.6 minus negative 7.4 times negative 0.7. On the bottom, we'd have 1.5 times negative 0.6 minus 2.2 times negative 0.7. Feed the calculator to find out what those values are. That would be negative 5.48 divided by 0.64, and then we would actually carry out that division. That would be negative 8.5625, which would be our x value. Now, as a fraction, that's actually a pretty nice fraction. That's over 16, but we're not going to worry about converting to fractions because the problem itself is written with decimals. Now, again, we already know the bottom determinant for y is the same value, so we don't need to reinvent the wheel here. We already know the bottom number is 0.64. There's no reason to redo that math. On top, the x column will be intact, so 1.5 and 2.2, and we'll be inserting our answers, 0.5 and negative 7.4, for the second column. So we're going to do 1.5 times negative 7.4 minus 2.2 times 0.5. And we're going to figure out what that value is by plugging it into the calculator. Is negative 12.2 divided by 0.64 is negative 19.0625. So that's your y value, is negative 19.0625, which is also a decimal over 16. But it doesn't matter what they are. We're going to write it as an ordered pair. So negative 8.5625, comma, negative 19.0625. And that would be the solution to our system of equations. Okay, next example. Also, I believe, a 2x2 system, and this might be our last 2x2 system. We will see when we get there. So again, we're going to start off with, here's x. Bottom determinant is the coefficient matrix, which would be 3, 1, 2, negative 1. On top, the y column is intact, but the x column is replaced with the answers. So that would be 0 times negative 1 minus negative 5 times 2 over 3 times negative 1 minus 1 times 2. So let's see here. That would be 10 divided by negative 5. So x is negative 2. For y, again, we do not need to reinvent the wheel here. We already know that bottom determinant is the same determinant. So we already know that equals negative 5. Up top, the x column will be intact, so 3 and 1. And the answers will replace the y column. So 0 and negative 5 will replace the 2 and the negative 1. So that's 3 times negative 5 minus 1 times 0, which would be negative 15 divided by negative 5, meaning that y is 3, and our solution is negative 2, 3. That, I believe, is it for Cramer's Rule 2x2.